Well, good morning or good afternoon, whenever you're watching this. We are back to day two of vectors. And so we'll get into more dealing with the vectors algebraically. We talked geometrically about how to add those, and then we talked about algebraically how to represent them. So we're going to get into more or less some of the operations algebraically as well, and some different ways to name them, as you see here. Talk about in terms of this magnitude and direction. And we also talk about, and we will show you what's called an IJ method as well. All right, operations on vectors. Well, we can take graphing paper, graph paper, and add two vectors given those. But now sometimes that's not the easiest thing to do. So with a lot of things is we want to find an algebraic way to represent them, an algebraic way to add them. Well, right now our algebraic way to represent them is a position vector. Remember, vector v1 comma v2 means it starts at 0, 0, and it goes to that point. So just a kind of quick recap, if you got a vector 3, 4, okay, that starts at 0, 0, and its end point is the point 3, 4. That tells you basically the directions going in the length. W is same thing. Those are position vectors. Well, if you add them, it's just like you would think. You add what would you think, the x parts together, v1 plus w1, and then v2 plus w2. When you subtract them, you're going to subtract the x parts, you're going to subtract the y parts. And then c times v that's a constant, that's a scalar. You just multiply both of them. So it's not anything different than you would think. And if we have things represented as position vectors, it's pretty easy to add and it's pretty easy to subtract them. Okay. All right, so let's take a look. We're still on those guided notes from yesterday. That should carry us all the way through. All right, v is the position vector 2, 3. W is the position vector negative 4, 1. We're just going to do a couple cases here. So for A, we want to add them. Well, so if I'm going to add 2, 3 plus negative 4, 1, then you just add 2 plus negative 4, which is negative 2, and you add 3 plus 1, which is 4. So that is the position vector. All right, well, we know how to do them geometrically, so just let me show you here. This is the vector v, 2, 3. This is the vector w, negative 4, 1. Okay, remember, we add them tip to tail, or the parallelogram method, but if I do that, and now the new vector, the resultant vector, would be this vector here, which is indeed negative 2, 4. So that way we don't have to draw it out every time geometrically. We can simply add the 2 with the negative 4 to get negative 2, 4. B, negative 2 times vector v. Well, that's negative 2 times 2, 3, which will be the vector negative 4, negative 6. So the negatives are going to make it go the opposite direction. The 2 is going to double the length. C, 2v minus w, 2 times vector v minus w. All right, well, 2 times v, you're just going to double those. That's going to be the vector 4, 6, minus the w, which is negative 4, 1. And then we're going to end up with 4 minus negative 4. Be careful there. That's going to be positive 8. And then 6 minus 1, which is 5. Whoops, you do not use a parenthesis. That is not correct. Make sure it is that bracket. And then D, all right, what does that notation mean? That notation means that is the magnitude. That is the length of that. So we have the vector 8, 5, which would be this vector right here. All we have to do, remember the length, which is basically the Pythagorean theorem. So the magnitude of 2v minus w equals a square root of 8 squared plus 5 squared, which is 64 plus 25, which is 89. So here's just some operations dealing with position vectors, okay? Adding them, scalar multiple, subtracting them, magnitude. And all these vectors start at 0, 0, and their endpoint will be given 2, 3, or negative 4, 1. All right, two vectors. Now we're going to get into what's called IJ method. Okay, it is essentially the same as position vectors. It's just a little bit nicer notation, a little bit easier to work with. And like I said, there's multiple ways to do these, and each way has its advantages. All right, the two vectors I, these are called the unit vectors. It is basically the vector 1, 0, which is just the position vector right along the x-axis. And J is a position vector along the y-axis, 0, 1. Any vector V can be written as an expression in terms of the standard unit vector. Okay, basically if you take whatever your length is times I, and then whatever your horizontal length is and whatever your vertical length is times J, that's how we're going to write this. So IJ method. So the vector 3, 4, all that means is I'm going to rewrite that as 3I plus 4J. Those are equivalent. Nobody ever writes this, but this is what you're saying. I is the vector 0, 1. Excuse me. I is the vector 1, 0. Plus J is the vector 0, 1. Well, 3 times that, it's just going to give you the 3 right there, and then that's going to give you the 4. It's going to be the same representation. 3I plus 4J. Negative 2, 6. Negative 2I plus 6J. And 4, negative 8. That's just 4I minus 8J. So in another equivalent way to write a position vector. Okay, equivalent. So typically we are going to use the IJ method over just we learned how to write a position vector. We know what it represents. Now 3I plus 4J, that is the position vector that starts at 0, 0. It ends at the point 3, 4. Operations, it would be very similar to binomials, like we would with a normal binomial. Think of that as an x and a y. So u minus v. You think of that as 4I minus 5j minus negative 2I plus 3j. 4I minus negative 2I, that's 6I. Negative 5 minus 3 minus 8j. Okay, same thing. So it's just basically adding and subtracting binomials. Now understand that u would be the same as the position vector 4, negative 5, and that v would be the same as the position vector negative 2, 3. They're equivalent. All right, well, what's 3u plus 2v? Well, I'm still going to use the u here and the v here. So that's 3 times 4I minus 5j plus 2 times negative 2I plus 3j. Well, just like we do our normal operations, distribute 3 times 4, 12I minus 15j plus negative 4I plus 6j. Okay, combine your i's, combine your j's. 12I plus negative 4 will be 8I, negative 15 plus 6 minus 9j. So that's 3u plus 2v. All right, and the last one on this slide, again, what does that notation mean? That means the magnitude. So I need to take 2u minus v. Well, u, remember, that's 4i minus 5j. And v is negative 2i plus 3j. So that's 2. 4i minus 5j minus, let's not worry about the magnitude yet, negative 2i plus 3j. All right, I'm just going to do a couple steps in one. 2 times 4 is 8 minus negative 2. That's going to give me 10i. 2 times negative 5 is negative 10 minus 3 gives me negative 13j. All right, once I got that, I want to find the magnitude. That's going to be the square root of 10 squared plus negative 13 squared. 100 plus 169 square root 269. So we can leave it like that. So magnitude right there, that's a constant. So it's got to be a square root of something or a whole number. 3u plus 2v, that's got to be in terms of ij, which is a vector. Okay, magnitude is not a vector, it is a scalar. It is a constant for that. We got the ij method. So we had to understand what a position vector was so that we can talk about ij method. Another way to represent vectors is what's called magnitude and direction. Okay, and we represented them geometrically, and we could see the magnitude and direction, but now we can attach a value for both. Now the direction, I'm going to jump down to this right now. The direction is always the measure of the angle between the positive x-axis and the vector. And it will be between 0 and 360 degrees. Okay, so that's going to be the direction. And we'll use 0 for if it's going directly to the right. So this is just to show you what's going on. Vector v has a magnitude of 10 and a direction of 40 degrees. Okay, that means this angle right here is 40 degrees. That means the length of the vector is 10 units, 10 inches, 10 centimeters, 10 miles, whatever units we're working in. W has a magnitude of 4, a length of 4, and a direction of 200 degrees. That means this angle right there is 200 degrees. That would have to be going into quadrant 3 and 0, 0. And U has a magnitude of 8 and a direction of 310. Well, that means that that angle right here is 310 degrees. Okay, so U has a magnitude of 10 and a direction of 300 degrees. All right, one of the big things that we're going to need to be able to do is we need to be able to convert from ij method to magnitude and direction, and from magnitude and direction to ij method. Well, basically, we need to know this point right here. Well, if I know this is 10 and I know this is 40 degrees, I need to know this point, which means I need to know this distance here, and I need to know this distance here. Well, think about this. This is a right triangle. I know the sine of 40 degrees is equal to y over 10. And I know the cosine of 40 degrees is equal to adjacent over hypotenuse, which is x over 10, which means my y value is going to be 10 times the sine of 40, and my x value is going to be 10 times the cosine of 45, not 40, 45. That's how we can figure out this right here, the coordinates of those points. Now, that leads to, hold on here. This case right here, this is how you express a vector in terms of its magnitude and direction in terms of I and j. This is the magnitude. You take the cosine of the angle times I plus the sine of the angle times j. Okay, so vector v is 10 cosine of 40 degrees I plus sine of 40 degrees j. Vector w from back here, okay, that is 4 cosine 200 degrees I plus sine 200 degrees j. U is 8 cosine 310 degrees I plus sine 310 degrees j. Okay. So what we can do now is we can take a vector and we can rewrite it in what's called ij form, where we know the x coordinate, essentially we know the y coordinate. All right, well, vector v in this case, and that is going to be this vector right here, just so you have a visual, has a magnitude of 6 and then a direction of 45 degrees. So to find the ij form, so vector v will equal 6 times cosine of 45 degrees I plus sine of 45 degrees j. If these are unit circle angles, we will use the exact values. 45 degrees is a unit circle angle. The cosine of 45 degrees is square root of 2 over 2 I. And then the sine of 45 degrees is square root of 2 over 2 j. Last thing I want to do is distribute the 6. Well, what's 6 times square root of 2 over 2? That's 6 radical 2 over 2, and that is 3 radical 2. So now my vector is 3 square root of 2I plus 3 square root of 2j. So we took the magnitude and direction, converted to what we're going to call ij form. We're telling you that the endpoint right there, that would have the coordinates. 3, it kind of helps you think about that. 3 radical 2, 3 radical 2. Okay, those are the end coordinates of it. And we attach an I to the x coordinate, a j to the y coordinate. All right, W is 8 240 degrees. Okay, 8 240 degrees. That is going to be that blue vector right there. We got to come up with the ij form. Well, W is going to be 8 times the cosine of 240 degrees I plus the sine of 240 degrees j. This is a unit circle angle. Okay, 240 degrees. That means that reference angle is 60. That means across from that is square root of 3 over 2. That means my adjacent side is 1/2. Since we are in quadrant 3, they are both negative. We have to take into account the signs. So W equals 8 cosine of 240 is going to be negative 1/2 I plus negative square root of 3 over 2j. W equals 8 times negative 1/2, which is negative 4i. All right, this whole thing is going to be negative. Now, 8 times negative square root of 3 over 2, well, 2 will go into 8 4 times. It'll give me minus 4 square root of 3j. That will be your answer. Okay, that'll be your answer for that. All right, let's take a look at this last one here. And hopefully, well, the last one from this part, there's still a couple more to go. 130 degrees is the angle. That is not a unit circle angle. Okay, that is not a unit circle angle, so we're going to have to use our calculator. This right here is 130 degrees. We still do it the exactly same as before. This is still called vector. This is vector v as well. So vector v has a length of 4, magnitude of 4, cosine 130 degrees I plus sine 130 degrees J. And get my calculator out. And you're just going to, so it's going to be V equals 4 times, what's cosine of 130? Cosine of 130. And it will give us the correct sign that we need, negative point, and I'm going to do the nearest 100, negative 0.64i plus sine of 130, 0.77. 0.77j. Now you need to multiply both of those by 4 to finish this off. So 4 times negative 0.64 and then 4 times 0.77. Okay, so I got negative 2.56i plus 3.08j. So if it's not a unit circle angle, we got to use rounded off values. All right, I'm going to pause this, and I'm going to have to finish it here in a little bit. It's actually, I got to do my office hours for a different class. So almost done, but let me pause this, and we will be back, hopefully. All right, well, I'm going to finish my recording, and I'm kind of doing office hours at the same time, so we'll see how this goes. All right, but I do want to get done with this. All right, now the next part, going the other direction. Find the magnitude and direction given either a position vector or given an ij vector. This is the same as 2i plus 3j. So if they give us that, or if they give us a position vector, we need to come up with the magnitude and direction. Magnitude is the length, direction is the angle. Well, it goes back to good old-fashioned right triangle trig. This is 2, this is 3. The magnitude of u is going to be the square root of 2 squared plus 3 squared, which is a square root of 13. Now, we need to know this angle. Now, when we're solving it, it depends on what quadrant we're in. This method will always find our reference angle. So I'm going to list it as theta prime. Theta prime is always going to be the inverse tangent of the absolute value of y over x. Y will be the 3, just like you would think of it as an ordered pair. X would be the 2. This is always going to be the case. You can see it from the triangle. It's a lot easier when you draw it out. You don't have to draw it out every time. You can immediately jump to inverse tangent, absolute value, 3 over 2. Well, they're both positive. So that means we just have absolute value of 3 halves, inverse tangent, 3 divided by 2. And that's 56, and we're going to go to the nearest 100, 56.31 degrees. So magnitude is square root of 13. Direction, 56.31 degrees. A lot of times we see magnitude and direction. It's not an ordered pair. Okay, that's just how we represent it, magnitude and direction. Okay, hopefully that makes sense. All right, second one here. And this is the Last one for today. Find the magnitude and direction of 5, -8, the position vector. That is the same as 5i minus 8j. ij method, position vector method are equivalent. We need to find the length. That's a little bit too long. Right there. We need to find the length, which is the magnitude. We need to find the direction. All right, magnitude. So it's going to be the square root of 5 squared plus -8 squared. Technically, you don't need to even put the negative in there because you're going to square it. It's going to become positive. You got 25 here plus 64, square root of 89. We can just leave it like that. All right, here's what we're doing. This will find our reference angle. We need to find this right here. That's going to be our final direction. That's going to be our final answer. But if you look at this right triangle, that's 8. That's 5. This will be my reference angle. It is always going to be the inverse tangent of the absolute value of y over x. Well, that's going to be the inverse tangent, the absolute value of -8 over 5. Well, if you just get in the habit of just using the positive values, you'll be fine. So that's going to give me the inverse tangent of 8/5. Well, what is that? Inverse tangent, 8 divided by 5. 57.99 degrees. That is not our direction. Our direction has to be this angle here. So in this case here, our direction is going to be 360 minus 57.99 degrees, which is 302.01. So a vector, the position vector, 5, -8, has magnitude, square root of 89, and direction of 302.01 degrees. All right, that concludes the notes for this part. Here's your assignment. Due Thursday by the old midnight bell. Got it? All righty, hang in there. I'm going to end this video now.